Hello everyone, welcome to double angle trig identities. We'll prove some double angle identities involving sine and cosine using our sum and difference formulas up here, in addition to some substitutions. Okay, so to begin with, we would prove the double angle for sine. So sine of 2a, which will be then equal to, using the addition formula of sine, we can rewrite 2a as a plus a. So we end up with sine a plus a. Now with our addition formula in sine up here, we can then substitute for sine a plus a, which will be sine a cos a plus cos a sine a. Now, as you can see, multiplication is commutative. So sine a, cos a, sine a are like terms, and we combine them to obtain our double angle identity for sine, which is sine 2 sine a cos a. Okay, next we look at the cosine of 2a identity. And again, as we did for sine, we're going to do cosine a plus a. And if you recall from our addition and subtraction formulas of sine and cosine, let's erase, it's cosine a not, so let's draw and go here, and it's cos a plus cos a not. And so we write cosine of a and cosine of a, and minus, note it is minus, not plus, sine a sine a. So by convention, cosine a times cosine of a will give us cosine squared of a, and then we have minus sine squared of a. So this is our base double angle identity for cosine, but we're able to make some substitution. Once we see cos squared a and sine squared a, we're thinking some identity we've seen in the past, which of course I hope you all remember. It is the trigonometric Pythagorean identity. So we'll make that substitution. I'll do that on the side that if we have cos squared a plus sine squared a equal to 1, then we can make some substitutions such that cos squared a equal to sine equal to sine 1 minus sine squared a. So with this, we can make our substitution for cos squared a, which will then give us 1 minus sine squared a, then minus sine squared a, and that will yield 1 minus 2 sine squared a. And so this gives us yet another version of the double angle cosine. And then Lastly, we'll get sine squared A by itself, which will then give us 1 minus cos squared A. So with that substitution from our initial initial identity, or first version of the double angle cosine, we can now go in and substitute for, sine squared A, which will then be cos squared A minus, remember your parentheses, we have 1 minus cos squared A. And when we simplify this, we end up with cos squared A minus 1 plus cos squared A, which will then give us 2 cos squared A minus 1. And so this is our third version of the double angle cosine. Note that at your convenience, you may choose to substitute either in this one here, or in this version here, or in this version here, depending on what problem you're solving and the convenience of arriving at your answer, depending on what identity you choose. So thanks again for watching, and we'll come with more identities involving double angle and other trig identities. Thank you.